Hello everyone, welcome back to This Would Have Helped Me. This is episode 2, where I'll show you the basics of GLSL shaders in GameMaker Studio. So usually when you go to your project, you can see this tab with shaders. You create a shader just out of curiosity, and you see a bunch of text that you don't understand. And so this is some help from the perspective of someone who knows just enough about shaders to tell you how they work, roughly, and how you can use them, and how they're incredibly powerful. So first of all, when you've got a shader, you have the vertex shader and the fragment shader. Now, when you're making a 2D game, you should probably only care about the fragment shader, so just close the vertex shader and keep it as it is. Now, here you've got varying vec2 vtext coord. This is a vector2, so it's kind of like a 2D array. It has, or a 2D table. It basically tells you the coordinate of the pixel it's currently changing. Because shaders work like this. They, when you set a shader and then you draw a sprite, then you start with the top left pixel, and then you check for the color of that pixel, or you check for anything. You edit this singular pixel, then you move on to the next one, and then the next one, and so on and so forth. You go through the entire image pixel by pixel, changing the color or position of every one of them. So this is the coordinates. You have vtext coord.x and .y, or you can reference both at the same time with xy. Then you've also got vv color, which is, as you would expect, the color, and it's a vector 4, so it's a 4-dimensional vector. You've got r, g, b, and a, which is alpha. If you don't know what these are basically red, green, and blue values, and the alpha, which is the opacity. So how can you use these? Well, to actually implement a shader, you're gonna have to go to draw, and if you want to draw a single object with the shader on, you'll just go to draw or draw GUI, whatever you prefer. If you want to draw the entire screen with it, then I'd recommend going to draw end, creating a surface, copying the application surface to that surface. Forgot how to use these. Destination, surf, 0, 0. Surfaces are basically like canvases that you can use to draw things out. Surfaces are basically like canvases onto which you can draw stuff, and the application surface is the one that is used by the game all the time. That's where everything is drawn. So if you copy, so if with this line you're basically making an identical copy of the screen that you have. Then the next thing you want to do is shader set. Then draw whatever you want to draw. In this case, surface surf 0, 0. And then always remember to shader reset. Otherwise, it's gonna use this shader for drawing everything else. It's the same with draw set alpha. One important thing to note with draw set alpha is that if you change it, remember to always change it back to 1. Otherwise, it's gonna draw everything on the screen with half opacity or whatever you set it to, and that's not what you want. So that's basically it, and remember to surface screen. Well, using surfaces is a bit more complicated, but this is the general structure. And now, if you want to give a shader other values, such as time, then you'll have to set uniform, and then float or vec2 or whatever it is you want to give it. In this case, I'll just give it float time, and I'll just make a simple sine wave shader. So then what you'll want to do is, in the create event of the object that is drawing, you'll have to set a variable, let's say shader time equals shader get uniform shader 0, and then as a string the uniform name, which we set here to be time, so we're gonna write it as a string time. And this is kind of the index of this uniform. And then while you're drawing, before you draw the thing, you have to shader set uniform, uniform f. So f stands for float. Uniform ID is going to be shader time, and the value which I'm going to set as current time, maybe over 1000. Alright, so now you've basically imported the time value into this shader. So now to actually set the new coordinates of every pixel, you'll have to make a new variable, let's say float new y equals vv_xcoord dot y, so then the y value plus sine of time, for example. And this will move the screen up and down, the whole screen up and down, depending on the time. And a very important thing to note here is that this final line is basically the deciding factor. So if you just keep it like this, nothing will happen. You'll have to change the coordinates to vec2 vv_xcoord.x, new y, so that the y will actually change. And if we do this, it should work, hopefully. There we go. It's a bit big. Oh yeah, I know why it's a bit big, but anyway, you can decrease, you can divide this by 16. Just make sure that you don't divide by 16 like this, because it will throw an error. Because this is an integer. Yeah. This is an integer, and this is a float. So you'll have to put 16.0. That's a very important difference between GameMaker language and GLSL. That GLSL is a much more, there you go, is a much more kind of strict language with its usage, so you have to make sure that everything you type in is correct. And now finally, if we just want to make it not entirely bow up and down, but move it depending on the x, we'll just put in vv_xcoord.x plus time. And there you go. You have a simple sine wave shader made in, how much? 5 minutes maybe? And the important, why should you use shaders anyway? Because they use the GPU instead of the CPU. So if you just set image, for example, image blend equals C gray, that calls into action the CPU. Whereas if you just use a shader to, for example, divide all the RG and B values by 2, then you'll use the CPU and you have more processing power in the GPU. Sorry, the other way around. Oops. And another very important thing is that they're just so useful. You can do so many things with it. For example, you can do the same thing but also for the X. And then you'll have kind of like a wobbly, sort of drunken effect. And that's what I did for Crystal Ninja, for when you take the pink mushroom. It's basically, I did this. Well, yeah, kind of. I also divided the time by some factor and the y by some factors. Just do a lot of playtesting and eventually you'll get it exactly where you want it to be. So that's it. That's the basics of shaders. Thank you for watching. This would have helped me, episode number 2.